This is the horizon line, or the eye level. Parallel lines, when seen in perspective, will seem to converge at this line. The point on the horizon where these lines converge is called the vanishing point. This is a cone of vision. It is the total area that a person or a camera can see. Our canvas will lie inside this cone of vision. Humans have a natural cone of vision of 60 degrees, and that is what mostly used for drawing. Anything more than 60 degrees, and the shapes will start having severe distortions. When drawing objects in perspective, make sure to provide good amount of distance between two vanishing points. If you draw the vanishing points too close to each other, the objects will have too much distortion. At once, there will only be one vanishing point inside the cone of vision. Having multiple vanishing points might look fine when drawing objects towards the center of the canvas, but when you move towards the edge of your canvas, you are drawing outside of your vanishing point, which will distort your objects too much and will completely change the shape of it. To equally divide a box in perspective, draw two diagonal lines on one side of the box. The intersection of the diagonals will give you the midpoint of the box. You can use this midpoint to divide the box into two equal parts. Draw this multiple times to create multiple divisions. To place objects at equal distances, first draw the object and then draw its perspective lines. Now place the second object at any distance you want and connect these two objects with diagonal lines. It will give you the midpoint of the object. Now draw a perspective line passing through this midpoint. Now draw a line from the top of the object passing through the center of the second object and meeting the perspective line. Now draw another object from that meeting point. You can use this method to draw electric poles on the road or to draw any repeating objects that are placed at equal distances. Now draw a horizon line and mark a vanishing point on it, and draw perspective lines coming out of that vanishing point. And now you can draw a box using these perspective lines. This is what you call a one-point perspective. Only one side will converge while the other two sides will remain parallel. To create a one-point perspective grid, first draw the horizon line and mark a vanishing point on the horizon line, and also mark a second point on it. Now draw two perspective lines coming out of the vanishing point, and then draw a horizontal line intersecting the perspective lines. Now draw a line from the other point passing through one of the perspective lines and meeting the intersection of the horizontal line and the other vanishing point. Now draw a horizontal line at this new intersection. Keep doing this multiple times to create your desired grid. The rectangles that this grid may or may not be a perfect square. To create a one-point perspective grid with a perfect square, we need to follow some more steps. First, draw a circle and draw a horizon line passing through the middle of the circle. Then draw a horizontal line passing through the center and extend it downwards. The center will be our vanishing point. Now mark a point on the horizontal line where it creates a 30-degree angle with the circle. It is where the observer or the camera is standing on the ground plane. Now mark another point on the horizon line, making an angle of 45 degrees with the station point. Now draw two perspective lines coming out of the vanishing point and draw a horizontal line intersecting the perspective lines. And then follow the same process that I explained to you earlier. This grid will be made of perfect squares. Now draw a horizon line, and this time we will have two vanishing points. Draw perspective lines coming out of these vanishing points and intersecting with each other. Now you can use these perspective lines to create your objects that will have two vanishing points. This is called two-point perspective. It will have two converging sides while one side will remain parallel. To create a two-point perspective grid, first draw a horizon line and mark the two vanishing points, and mark another point somewhere in the middle of these vanishing points. Let's call them A, B, and C. Draw two perspective lines coming out of the vanishing point A, and then draw a line from vanishing point B, intersecting the lines from vanishing point A. Now draw a line from C passing through a perspective line from A and meeting the intersection of A and B. Now draw a perspective line from B passing through this new intersection. Now draw another line from C passing through the perspective line from A and meeting at this new intersection point of A and B. Now you can just keep repeating this process to create your grid. Now again, this grid may or may not have perfect squares. To create a grid with perfect squares, draw a circle, Then draw a horizon line passing through the center of the circle, and then draw a vertical line from the center of the circle and extend it downwards. Now mark a 30-degree station point on the vertical line and 45-degree points on each side of the circle. These 45-degree points will be our two vanishing points. Now just follow the same process that I explained you earlier, and you will have a grid in 2-point perspective with perfect squares. Now draw a horizon line and two vanishing points on it. And now we will have a third vanishing point, either above the horizon line or below the horizon line. It will depend on where the viewer is looking at. Now draw perspective lines coming out of these 3 points, intersecting with each other. And now you can use these perspective lines to create your objects with 3 vanishing points. This is called 3-point perspective. The objects will have no parallel lines in this. This is the most realistic form of perspective drawing because naturally this is how humans perceive 3D objects. Now draw a horizon line and mark the 2 perspective points on it. And now we will have 2 more vanishing points, one above the horizon line and one below the horizon line. Now draw normal perspective lines from the right and the left vanishing points. Draw them both below and above the horizon line, and then connect the top and the bottom vanishing points with these curved lines. Now you can use these lines to create your objects, and this is called a 4-point perspective. In this type of perspective, you don't have to worry about the height of the object. You can draw any object from top to bottom without worrying about the space on your canvas. Now draw a circle and divide it into 4 parts from the center. This will give us our 5 vanishing points. One on left, one on right, one on top, one on bottom, and one in the center. Now draw these perspective lines coming out of the center vanishing point, going in all directions. Then connect the top and the bottom vanishing point with curved lines. Do the same with the left and the right vanishing points. Now follow these perspective lines to draw your objects. This is called the 5-point perspective, or also called the fisheye perspective. Using this perspective, you can draw anything within the view of 180 degrees. Now this is our viewer. He is standing on the ground plane, and there's a box on the ground plane and one floating above the ground plane. And our viewer is looking straight towards the horizon. In this situation, this is what the canvas will look like. The horizon line will lie at the center of the canvas, and one box below the horizon line and one box above the horizon line. Now if the viewer looks down at the box on the ground, this is what the canvas will look like. The box on the ground will become the center of the canvas, and the horizon line and the box on top will go above or even out of the canvas. In reality, the positions of these objects or the horizon line is not changing. What's changing is the position of the cone of vision of the viewer. Now if the viewer looks up the box, this is what the canvas will look like. What this means is that the position of the horizon line depends on where the viewer is looking at. If he looks up, the horizon line goes down, and if he looks down, the horizon line goes up. Well, this is it for the video, and I will see you in the next one. Goodbye.